Hello dear Phasmatic friends! Today we're going to study how to make operations with scientific notation, but considering significant figures. Let's go! First of all, I'm going to tell you that it is not the same to add and subtract than multiplicate and divide. So for addition and subtraction you must have 10 to the power of 2, for instance, and 10 to the power of 2 also. The same power with the two terms. For the subtraction, the same. If here you have 10 to the 5th power, here you must have 10 to the 5th power. And if you have here 10 to the 4th power, also here. But here you have another way to do that. You can write it without scientific notation, and add those numbers. So here, if you have times 10 to the 2nd power, you are gonna move the decimal point 2 places to the right. And if it was negative, 2 places to the left. Okay, so here we have 345 because we are moving the decimal point 2 places to the right. Plus, here we are going to move the decimal point 3 places to the right. 1, 2, 3. So 4,383. Now you add those numbers and you get 4,728. Finally, I'm going to write it in a scientific notation. Remember, for scientific notation, you must have one number that is not a 0, after that the decimal point, and after that the other numbers times 10 to the, and here 1, 2, 3 places. If I put the decimal point here, there are 3 places to get to the real decimal point. So times 10 to the 3rd power. But wait a second. We are going to talk about significant figures. What is a significant figure? The numbers that are important here. For instance, if you use a weighing machine to get this number and another weighing machine to get this number, but this weighing machine is more precise than this weighing machine, you are going to consider only 3 significant figures. It is useless to consider 4 significant figures if here you have a weighing machine that can only measure with 3 significant figures. So the answer must have only 3 significant figures. So 1, 2, 3, you are going to round the last number. If you have more than 5, you are going to round the last number. If you have less than 5, you leave it like that. So here the real answer will be 4.28 times 10 to the 3rd power. And that's it. For the subtraction, same. Here we have 4 significant figures, and here we have 5 significant figures, so the answer must have only 4 significant figures. And for make it easier, when you have experience, maybe you can write this number times 10 to the 5th power. But now we can write this number 1 and you are going to move the decimal point 5 places to the right. 1, 2, 3, 4, 5. We're going to add 2 zeros. So you have this number. Minus, and here we're going to move the decimal point 4 places. 1, 2, 3, 4. 9, 7, 8, 7, 6. And the answer is 87,524. But now you write it in a scientific notation. Remember, only one number that is not a zero, the decimal point, and after that the other numbers times 10 to the, and you count. If you put the decimal point here and the real decimal point is there, 1, 2, 3, 4. 4 places. But remember, we have here only 4 significant figures. Here 5, it is useless. To write 5 significant figures, you need 4. So 1, 2, 3, 4. You are round the last number. Because here I have a 4, I'm not going to rise this number. We're not going to rise this number. No. We're not going to rise this number. So you only erase this number, and the answer is 8.752 times 10 to the 4th power. And that's it. For multiplication and division, the same logic with the significant figures. But here, you are going to take the coefficient, multiply it by the coefficient, and after that, the exponents. If you have the same base, you are going to add those exponents. And for division, you divide the coefficients, and for the rest, you are going to subtract the exponents, because you have the same base. And remember, in algebra, when you divide same bases, you subtract exponents. And when you multiply same bases, you add exponents. Here, 1.35 times 2 is 2.76 times 10 to the 2 plus 3, 5th power. But remember, you have to see how many significant figures do you have. Here I have 3, here I have 1. So the answer must have only one significant figure. So here it is the first significant figure, but here it is a number higher than 5. So you round this number. 2 rises to 3, and the answer will be 3 times 10 to the 5th power. Here, 2.8 divided by 1.4, it is 2 times 10 to the 6 minus negative 3. You write it? 6 minus negative 3. Negative and negative. Negative times negative. 6 plus 3 equals 9. So 2 times 10 to the 9th power. But remember, here you have 2 significant figures and here 2. But here you have only 1. You must add a 0 to have 2 significant figures. And that's it, dear friends. Thank you very much for watching this video. See you next time.